Hello, this problem is from GATE 2023 and this problem belongs to control system subject. So the question says that consider a unity gain negative feedback system consisting of the plant GS given below. GS is given as 1 divided by S minus 1 and a proportional integral controller, that is PI controller. Let the proportional and integral gain be 3 and 1 respectively. So Kp and Ki value is given as 3 and 1 respectively. For a unit step response input and the input function is that unit step, the final values of the controller output and the plant output respectively are. So we have to find the steady state value of the controller and the plant. So before we begin this problem, we will first have a quick recap on the theories behind this problem. So the in the open loop control system, we don't have a feedback system, and this is simply printed by one controller and one plant, and there is no feedback in the system. While this closed loop control system be having feedback path, there may be some gains in the feedback path also, and if and there are two types of closed loop control system. It might be positive feedback or negative feedback, and this apart from controller and plant, one comparator comes into this picture. So we can represent this closed loop control system by a block diagram given below. So how we can find the transfer function of this block diagram? We usually directly we found using this expression. So if this forward path represented, that is combined as controller and plant, is expressed as n1 divided by d1, and this feedback path is represented as n2 divided by d2. So we can directly write the transfer function as n1 d2 divided by d1 d2 plus n1 n2. We will see this how we will apply this transfer function expression in this problem. So positive comes for negative feedback in the denominator. We can see here positive comes in the denominator. This is for negative feedback system, negative feedback closed loop control system, while negative comes in the denominator side for positive feedback closed loop control system. Okay, all right. So this is for the finding the transfer function for the closed loop control system. Now we will see that initial value theorem and final value theorem. So the first is initial value theorem. What is initial value? So the value of function at t is equal to 0 plus is called the initial value of a function. Usually what happens is that if we are having the function given in t domain, so we can directly find the initial value of the function. But if the function is given in S domain, we cannot directly find the value of we cannot directly find the initial value because we need to first the convert this function in S domain into the function in time domain. So it will take some time, and then after finding the function in time domain, we can apply put the t is equal to 0 plus. So from there we can find the initial value. But if we want to find the initial value in S domain, then we have to use the initial value theorem. So this is the expression, means just you if you find the initial value from the S domain, you need to put the S tends to infinity and multiply fs by S. So we will get the initial value function at t is equal to 0 plus. So we can see that time domain and frequency domain are reciprocal to each other. So if we are putting the t is equal to 0 plus and if we are putting S is equal to infinity in the SFS function, then we are getting the same value. One thing we have to mention that we cannot directly apply initial value theorem to any function. So there are some conditions must be met before applying the initial value theorem. The conditions are, first one is that it is applicable only when ft is equal to 0, t tends to 0. So it is positive sided function. For negative sided, it must be 0. And second condition is that ft must not contain any impulse or discontinuities at t is equal to 0 plus. So both these conditions should be met for the function before applying the initial value theorem, otherwise it is not applicable. Okay, all right. So this is initial value theorem. Now Similar to the initial value theorem, we can also find the final value theorem. So what is final value? Final value of function, it is the value of a function at t is equal to infinity. This is also called as a steady state value. So if we are putting t tends to infinity in ft, then in S domain you need to put s tends to 0 and the fs should be multiplied by s. So this is the final value expression, final value theorem expression. You need to remember it. And is the Laplace transform of ft. And there are also some condition for final value theorem also. First condition that all the poles of fs must lie in the left half of s plane. And the second condition is that fs must not have more than one pole at origin. So both these conditions should satisfy before applying the final value theorem. Otherwise, it is not applicable. Okay. So now let us come to the problem and we will start solving the problem. So whatever data we are having given, we just represent the data into block diagram. So this is RS and we are having one comparator and then we are having PI controller and plant is given and then we will get output and it is given that unity gain negative feedback system is there, and it is also given that input function is unit step function. So we represent in Laplace transform as 1 divided by s, and the Kp and Ki value are given as 3 and 1 respectively. So we have represented like this, and if we aggregate controller and plant, then we will get 3s plus 1 divided by s into s minus 1. Now here we have to find the steady state output of the system and the controller. So we need to find the x infinity and y infinity. So here we require the final value theorem. Before that, we also need to calculate the transfer function for the system. So just applying by s divided by rs is equal to n1 d2 divided by d1 d2 plus n1 n2. So n1 is here 3s plus 1, d2 is 1, d1 d2 is d1 is s into s minus 1, d2 is 1 plus n1 n2. So n1 is here 3s plus 1, n2 is 1. So we get value for the transfer function, for this transfer function as 3s plus 1 divided by s square plus 2s plus 1, which is nothing but s plus 1 whole square. So we will get ys value as 3s plus 1 s plus 1 whole square into rs, where rs is the Laplace transform of unit step function. So we will get the ys 3s plus 1 divided by s into s plus 1 whole square. Now we will apply the final value theorem. So here we will apply the final value theorem, which says that the value of ys at infinite time, it should be, we can calculate by putting s tends to 0 and multiply by s with s. So we will get value as limit s tends to 0 3s plus 1 s plus 1 whole square, because s cancelled out. So be on putting s is equal to 0, then numerator will be 1 and denominator will also 1. So the final value will be 1. So the final value of the output will be 1. Now we will find the final value of the controller output. So we are finding the controller output at the steady state. So we know that from the block diagram we can write like that xs into 1 divided by s minus 1 is equal to ys. So xs is equal to ys into s minus 1. So we can write xs is equal to 3s plus 1 into s minus 1 divided by s into s plus 1 whole square. So again we have to apply final value theorem for finding the x infinity, because this function is given in s domain. So we cannot we cannot directly apply the t tends to infinity. So we have to apply this final value theorem where limit s tends to 0, uh, x xs will give the value as minus 1. And here again x cancel out, on putting s is equal to 0, numerator we will get minus 1 and denominator we will get 1. So the final value will be minus 1. So from here we can see that the controller output at infinity time is minus 1 and the whole system output is 1. So from the options we can see that D option is correct. So that's all for this problem. Thank you.